Hi, second grade teachers. Today we are going to take a look at Unit 5, representing sums and differences within 1,000. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 5. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 5. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has two AKS, AKS 2 and 5. Under the AKS, you will find the Indicators of Achievement, or IOAs, that we are teaching at this time. Notice for AKS 2, we are focusing on 2B, 2C, 2D, and 2E, and IOA 2A is also included as an ongoing IOA. For AKS 5, we are focusing on IOA 5D. You will also notice that we have provided you with the state coding at the end of the IOAs so that if you are looking up resources on the Georgia DOE website, you are able to find the IOA that is related to the GCPS IOA. IOAs without the state coding at the end are specific to Gwinnett. AKS 2 involves students continuing to add and subtract numbers using a variety of strategies based on place value, part whole, and properties of operation. In Unit 5, students will continue to add and subtract numbers within 1,000. Students will also continue to work on building fluency with addition and subtraction within 20 and strategies within 100. Let's take a closer look at the IOAs that will allow students to demonstrate mastery of the AKS. In IOA 2A, students will continue to work on building fluency with addition and subtraction within 20 using a variety of mental part-whole strategies. This is an ongoing IOA. Reaching fluency is an ongoing process that will be continued through number talks. Students should know all sums of two one-digit numbers by the end of second grade. IOA 2B, students will continue to use tools such as base 10 blocks and or drawings, a thousands chart, or visual number lines to discover the pattern of 10 more and 10 less and 100 more and 100 less than a given three-digit number. In IOA 2C, students will continue to solve authentic mathematical problems involving addition and subtraction of two-digit numbers. Unit 5 will also include adding up to 4 two-digit numbers using strategies based on place value and properties of operation. The focus will be on solving problems within 1,000. In IOA 2D, students will add and subtract fluently within 100 using strategies based on place value, properties of operation, and or the relationship between addition and subtraction. They will also use numerical reasoning and student-chosen flexible methods and strategies to solve mathematical problems accurately and efficiently. These mathematical problems will involve all problem types. In IOA 2E, students will add and subtract numbers within 100 in the context of one- and two-step word problems, including a variety of problem types that have unknowns in all positions, including result unknown, change unknown, and start unknown. They will also use drawings, objects, and equations with a symbol for the unknown, to solve one- and two-step problems. Our suggested pacing, which you will see in Chapter 2, will show different clusterings of IOAs 2C, 2D, and 2E have been clustered, and also IOA 2B and 2C have been clustered. And then finally, you'll see 5D clustered with 2C, 2D, and 2E, and we will see this more once we get into our pacing guide. AKS 5 is our measurement and data standard. In Unit 5, students will revisit asking questions and answering them based on gathering information, observations, and appropriate graphical displays to solve problems relevant to everyday life. Unit 5 will focus on IOA 5D. In IOA 5D, students will continue to formulate statistical investigative questions to explore an authentic situation in their classroom, pose questions, determine up to 4 categories of possible responses, collect data, represent data on a picture graph and/or a bar graph using a single unit scale, and interpret the results. Using the information from the graph, students solve simple one-step relevant word problems related to addition and subtraction. In this portion of the video, we will look at the pacing guide to see how the AKS and IOAs have been paced over the course of the unit. Our pacing guide is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS or IOA and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. At the top of the pacing guide, you will see the name of the unit, the big ideas for the unit, and the suggested pacing. This unit will focus on representing sums and differences within 1,000, and the suggested pacing is 4 weeks. The unit consists of adding and subtracting within 100 to solve 1- and 2-step word problems, using drawings and equations with a symbol and adding and subtracting fluently within 100, using strategies based on place value, properties of operation, and/or the relationship between addition and subtraction. It also includes solving problems involving addition and subtraction of 2-digit numbers using part-whole strategies, as well as adding up to 4 2-digit numbers using strategies based on place value and properties of operations. These mathematical problems involve addition and subtraction within 1,000. And finally, it involves analyzing graphical displays of data to answer relevant questions and use the information from the graph. Using the information from the graph, students will solve simple one-step relevant word problems related to addition and subtraction. The pacing guide is set up with a list of AKS and IOAs, which have been strategically clustered together. This is followed by our suggested pacing. Specifically, the left column here provides the learning progressions for the AKS and IOAs, whether this be concrete, representational, abstract progression, or the progression between specific learning targets within the IOAs. It also has suggested manipulatives at the end of the column. The right column provides resources to guide instruction, such as GCPS, traditional and task-based lessons, and Georgia DOE resources. Unit 5 begins with the clustering of IOAs 5D, 2C, and 2D for a suggested 2 days. We are starting with this clustering of IOAs to allow students to apply the flexible and efficient strategies they have learned to add and subtract to solve problems using information from a bar graph. The progression over the 2 days consists of students participating in a Georgia DOE learning plan. Let's take a look at this Georgia DOE learning plan. As you can see, this learning plan begins with a diagnostic assessment that teachers could choose to give just to formatively assess how well their students are doing with adding up to 4 2-digit numbers. Then it consists of constructing a bar graph, and then progressing to solving subtraction problems using information from the bar graph, as you can see here. And then students will also add and subtract 2-digit numbers, as well as add and subtract up to 4 2-digit numbers within 1,000, which you can see with this activity. And then finally, on the second day, which is apply and reflect, the students will have the opportunity to practice the adding and subtracting fluently within 100 using strategies based on place value, properties of operation, and/or the relationship between addition and subtraction. After students have solved addition and subtraction problems using information from a graphical display, we will focus on IOA 2C for a suggested 2 days. The focus here will be adding 4 2-digit numbers. In the previous unit, Unit 4, students were exposed to 4 2-digit numbers within 1,000 for 5 days. The progression over the 2 days consists of students using representational tools like the number line to add 4 2-digit numbers and progress to reasoning about place value strategies and properties of operations. The rationale here is to give students another opportunity to move toward proficiency using student-selected strategies based on place value to add 4 two-digit numbers within 1,000 and reasoning about place value strategies and properties of operations. After adding 4 two-digit numbers, we will revisit IOAs 2C, 2D, and 2E. Students will continue to use multiple strategies to solve addition and subtraction word problems within 1,000. Students will solve 1- and 2-step word problems using drawings and equations with a symbol for the unknown to represent the problem for a suggested 2 days. Teachers should keep in mind all 2-step word problems should be within 100. The 2-day progression includes using strategies based on place value and properties of operations to solve 1- and 2-step word problems. Students will use drawings, number lines, and/or thousands charts and equations with the symbol for the unknown to represent the problem. Addition and subtraction is within 1,000. This was done to give students another opportunity to continue working with a variety of problem types. However, keep in mind, should you choose to use the 2-step word problems, remember, all sums and differences should be within 100. After solving problems involving addition and subtraction of 2-digit numbers using part-whole strategies and adding up to 4 two-digit numbers within 1,000, we will revisit IOA 2B clustered with IOA 2C for context for a suggested 7 days. Students will use base 10 drawings, thousands charts, and/or visual number lines to discover the patterns of 10 more and 10 less and 100 more and 100 less than a given 3-digit number. The progression over the 7 days consists of students using base 10 drawings to solve problems involving adding and subtracting 10 and/or 100 to a given 3-digit number. This also includes adding and subtracting multiples of 10 and/or 100. We are starting here because in Unit 4, students had prior experience with using base 10 blocks to solve problems involving adding and subtracting 10 and/or 100 to a given 5-digit number. Students will then progress to using thousands charts and then the number line, and finally recognizing and reasoning about the patterns when adding and subtracting 2, 10, and 100 and multiples of 10 and 100. And you can see that progression here ending in the abstract. Finally, in Unit 5, we will revisit IOAs 2C, 2D, 2E, and 5D for 6 days. The main focus of the first 2 days will be to revisit IOA 2C, 2D, 2E, and provide another opportunity for students to work with 2-step word problems within 100. For the remaining 4 days, IOAs 2C, 2D, 2E, and 5D, as you can see here, have been clustered together to give the students another opportunity to apply the flexible and efficient strategies they have learned to add and subtract to solve problems using information from a bar graph. Chapter 3 of the video will highlight specific instructional strategies that will be utilized in Unit 5. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. We are going to be looking at strategies for IOAs 2C, 2D, and 2E. For these IOAs, students will need to be able to solve problems involving addition and subtraction of 2-digit numbers using part-whole strategies, and add up to 4 two-digit numbers using strategies based on place value and properties of operation. They will need to be able to add and subtract fluently within 100 using strategies based on place value, properties of operations, and/or the relationship between addition and subtraction. And finally, use addition and subtraction within 100 to solve 1- and 2-step mathematical problems involving all problem types by using drawings and equations with a symbol for the unknowns numbers to represent the problem. Our focus today will be on solving 2-step word problems within 100. Many students struggle with solving word problems because they lack the understanding of the meaning of the operation. In 2nd grade, students work with 2 operations, addition and subtraction. I want to share with you a strategy to support your students with developing an understanding of the two operations, addition and subtraction. Creating a two operations anchor chart with your students will be very helpful and becomes a reference point for your students throughout the year. You can start by presenting this question: what happens or what action occurs when we perform math operations? Have your students stop and jot what actions occur when they perform addition and subtraction. After students have jotted down their responses, you will want to gather their thoughts on an anchor chart similar to the one shown here. For example, with addition, they may say things like join groups, put groups together, combine groups. And then for subtraction, you may hear, or on your anchor chart, you can include separate groups, take groups apart, remove groups, and compare. After you and your students have gathered all of their thinking in regards to the action for each operation, have the students look at both operations and make generalizations about them. The biggest generalization here is they're totally the opposite of each other, if you notice. And we want students to be able to notice that. These are important ideas, important big ideas we need our students to understand. So you may be wondering, why go through all of this when we can just teach keywords to go with the operation? Keywords don't work. And here's why. Keywords don't work because students do not have to make meaning or make sense of the situation. Keywords can be misleading. Many problems do not have keywords. And finally, keywords can't be used when solving multi-step word problems. Today, we're going to look at a couple of examples why, but I wanted you to know that all of this research was pulled from John Vander Waal's book, Teaching Student-Centered Mathematics. So let's take a look at some examples of why keywords can be misleading. You can see in this first problem, it says, Maxine gave 28 stickers she no longer wanted to Zandria. Now Maxine has 73 stickers left. How many stickers did Maxine have to begin with? When students see the word left, they think they need to subtract. If that is the case, then they'll subtract 73 minus 28. But that is not what's happening in the problem. We're being asked to find how many stickers did Maxine have to begin with, which means students will need to add 28 and 73 to find the answer. Another example why keywords can be misleading is this next problem. It says 6 rabbits were sitting on a hill. Some more rabbits joined them. Now there are 12. How many rabbits joined the first group of rabbits? Again, if students see the word more, students will associate with addition, and they will add 6 and 12. But that is not what's being asked here. This is what's called a change unknown problem. So we're going to have to find the difference between 12 and 6 to figure out how many rabbits joined them, or the change in the problem to create 12. So these are some examples of why keywords can be misleading. Now let's look at some other examples of problems that don't even have keywords. This first problem says Maxine has 14 flowers. How many can she put in a red vase, and how many can she put in a blue vase? Well, there's nothing here to tell us what to do in this problem, but a closer look shows us that 2 of the add-ins are missing, and that we're going to need to decompose the number 14 as many ways as possible to determine how many flowers can be put into the red vase and how many can be put into the blue vase. Now let's look at this second problem. There are 14 apples in a bowl. 8 of them are red and the rest are green. How many apples are green? There is nothing here to tell us whether to add or subtract. We have to figure out what's going on in the problem. We can see that there are a total of 14 apples. Part of them, or 8 of them, are red, and part of them are green. We do not know one of the parts to this problem. So we're going to need to subtract the 8 red apples from the 14 to find out what's left or how many is green. After talking through why keywords don't work, it will be very important to return to the anchor chart that you saw earlier and use it to develop students' understanding of addition and subtraction and make connections to their actions. If students can do this, they will grow in their ability to solve contextual word problems that involve addition and subtraction. Now that we've had some learning on why keywords don't work, let's take a look at a two-step word problem. This time of year, your students should be using more representational and abstract strategies. So that's what you're going to see as I model this problem today. So let's take a look at the problem. Sabrina rode her bike 36 miles on Saturday. On Sunday, she rode her bike 18 miles further than she did on Saturday. How many miles did Sabrina ride her bike over the weekend? So in thinking about this problem, I need to make sense of what's happening. We've learned we really need to focus in on what's happening on the problem. We can keep in mind our chart that we made, addition situations and subtraction actions that occur in a problem. We talked about addition is joining groups, put groups together, combine groups. And subtraction, you'll see actions like separating groups and taking groups apart, removing groups, or even comparing. So let's take a deeper look at our word problem today and kind of jot down what's going on. So first I can see that Sabrina rode her bike 36 miles on Saturday. So I'm going to make a note of that. Sabrina rode bike 36 miles on Saturday. Okay. Then I can see in the problem that Sunday, she rode her bike 18 miles further than she did on Saturday. Let me think about what this means. So Sunday, she rode 18 miles farther. Now, what this means is that I really don't know how many miles Sabrina rode on Sunday, but I'm going to keep going and still keep trying to figure out what's happening in the problem. And then finally, I need to find out how many miles did Sabrina ride over the weekend. So how many miles Sabrina rode over the weekend. Now, this tells me over the weekend, I know that the weekend consists of Saturday and Sunday. So I need to keep that in mind as I begin to solve my problem. I can tell looking at this problem, we know when Sabrina rode on Saturday, she rode 36 miles on Saturday. Sunday, we don't know, but we do have some information about Sunday. We know that she rode 18 miles farther on Sunday. So I'm going to need to figure that out in order to be able to answer my final question, which is how many miles she rode over the weekend, which includes Saturday and Sunday. So I can tell this is a two-step word problem. So let me think about my first step. Like I mentioned earlier, I know Saturday, but I need to find out Saturday and Sunday to answer my final question. I need to figure out in my first step, how many miles did Sabrina ride on Sunday? Well, I know she rode 18 miles farther. And farther tells me this number is going to be larger than Saturday because she went some extra miles on Sunday. And we know the extra miles that she rode was 18 miles. So our equation to set this up is going to be 36 plus 18 equals question mark. I don't know how many she rode on Sunday, but I'm going to figure out how many miles she rode on Sunday so that I can answer my final question, how many miles she rode over the weekend. Now, remember I mentioned earlier, our students are working more with those representational strategies. So we could use a number line here to figure out Sunday's miles. And we can start here with 36. And we can make some friendly jumps on our number line to figure out the answer to this. So I'm going to jump 10 first of my 18. And that puts me at 46. And I still have 8 more to jump, but I know if I jump 4 more, it puts me at a friendlier number of 46 plus 4 is 50. And then I'm going to jump another 4. 4 plus 4 is 8 to get 54. Okay? So I know that on Sunday, Sabrina traveled 54 miles. Now, as I mentioned earlier, your students are starting to move into those more representational and towards abstract strategies. So what some students may decide to do here, if they're not using the number line and they're in that abstract environment and they're seeing those strategies through number talks, you may see some students that decide they want to compensate. So they could have 36 plus 18 equals the unknown. And they could look at this as, I'm going to compensate to make this 1820. So I'm going to take 2 from my 36 and add those 2 back to my 18, which will make my 18 a friendly number now, 20. So 36 becomes 34 because I took that 2 away and I joined it with 18 to make it a friendlier number. So now I have 34 plus 20, and I know that that equals 54. You also may see some students that just off place value, they add their 10s and add their 1s. So out of this same equation, some students may say 30 plus 10 is your 3 and your 3 and your 1 that's in the 10s place. 30 plus 10 equals 40. 6 plus 8 in your 1's place equals 14. And then students can add those two partial sums together to get 54. 54 students. 54 miles were rode on the bike by Sabrina on Sunday. And that's what we're trying to figure out. And then thinking through even another strategy that students might use, another abstract strategy, they may decide to use expanded form. So they'll take the same equation and they'll expand each number, showing the value of each digit. So the 36 would be 30 plus 6. And then you're going to add that to your 18. This is the number that represents your 18. 10 plus 8. And then you may see them add this way. 6 plus 8 is 14, plus 30 plus 10 is 40. And we know that answer is 54 as well. And that's all of the strategies that you may see just from that first step. Because remember, going back to the problem, we want to keep them aware of what's happening. We're trying to figure out Sunday because we had information about Sunday, but we didn't know exactly how many miles she went on Sunday. So now that's our first step. Now that I know Saturday, which is 36 miles, and I know Sunday, circle that, and I know Sunday now is 54 miles. Now I can solve my final question here. How many miles did Sabrina ride over the weekend? So that equation is going to be Saturday and Sunday. So if we go back to our chart here, what are we doing with Saturday and Sunday? We are joining those together. We're putting them together. We're combining them. So we know that we're adding. So let's write that equation. Saturday, 36, plus Sunday, which we know is 54, equals, and that's what we're trying to find out. So going back to that representational strategy of the number line, I'm going to start with 54 this time, the larger number. And we can make our jumps on the number line to figure out the answer to this question. So I'm going to jump 20. And that puts me at 74. And I know I've jumped 20 of my 36. So I'm going to jump another 10. That puts us at 84. And out of the 36, I've jumped 30. I have 6 more to jump. Oh, that's a friendly number for me because I know that that's going to give me 90. So I'm just going to jump the entire 6 to get 90. So I can see that over the weekend, Sabrina rode 90 miles. Now, as I said before, you may have students using those abstract strategies right now. We've looked at a couple here based on place value. They could do the same thing here with this one. They may decide to do the 10s first and add those, and then add the 1s and then add those together. What would that look like with this equation? It would be 30 plus 50, which gives us 80, and then 6 plus 4, which gives us 10. I can see a lot of students doing this because these numbers, all of them are really friendly. And then 80 plus 10 equals your 90. Okay? And the same goes with that expanded form. We would expand 36 like we did before. It's up a little. So that'd be 30 plus 6. And then we expand out this time the 54, which we learned was Sunday's miles, 50 plus 4. And we're seeing some similarities here. It makes it very friendly for students. So teachers, you really should expect your students to start doing this, especially since we've been doing the number talks in our activators since first quarter. So 6 plus 4 is 10. And we know 30 plus 50 is 80. And 80 plus 10 is 90. So going back to our problem, we want to answer our question, how many miles did Sabrina ride over the weekend? We know after completing our 2 steps, our first step was figuring out Sunday. Our second step here was the final question, how many she rode over the weekend, Saturday and Sunday. We know that Sabrina rode her bike 90 miles over the weekend on Saturday and Sunday. And here's our 90 miles proof here from the number line and from our strategies based on place value that are more abstract. But teachers, just be aware that your students will solve what works for them, the efficient strategy that works for them. And I just wanted to make sure that you saw some of the ways that you might see them work the problems in your classroom. Remember, teachers, this video highlighted specific instructional strategies that can be used in this unit. Please refer to the Analyzing the Standards, or the ATS, for guidance on additional instructional strategies for each IOA. So, which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. From the Georgia DOE's Comprehensive Grade Level Overview. To ensure completion credit in PD&E, please be sure to complete the following Google form. Please scan the QR code in order to get the Google form. Thanks for watching.